Hi all. See this, in this particular problem we are need to find out the sum of the given series, okay, and the number of series is see that 10 terms, right? So the first job is to observe the series and try to find the general term, right? So always try to find the general term because this is the easiest way to solve this kind of problem, okay? Let's go ahead, okay? Now see that in that particular problem, right, what we are going to observe. So first we have to consider that series, right? So let's got that series. Let's go ahead and that series, okay? So what should I did it here, right? We just considered that particular series, and in that particular series, right, it's a series of mixed fraction, right? So we just convert the mixed fraction in a normal fraction, right? So let's go ahead. Now observe that, right, in that each and every cases except that 4, right, all the terms are written in the form of like 8 by 5, 12 by 5 something, right? So this term also can be written as 20 by 5, right? Let's go ahead and write down stuff. Why? Because we need to observe the general term, okay? So now see that how the terms are take care of that. It becomes a AP series, okay? So the numerator, right, is a AP series where first term is 8 and the common difference is actually 4, right? So therefore that general term can be written as 8 plus n minus 1 multiplied by d, that is 4, right? So therefore this can be easily written as sum of 8 plus n minus 1 4 divided by 5 whole square, right? So obviously the numerator can be little bit simplified, so that gives you 4n minus 4 whole square divided by 5, right? That's it. So therefore that here this 4 plus 4n by 5 whole square can be taken out and the remaining thing can be expanded, right? So let's go ahead and see that, okay? So here we see that gives you 16 by 25 and n goes from 1 to 10, right? That's it. We just take out that in common and all this stuff. So here we can go ahead and apply this in two techniques, right? First of all, we can expand this. That's it. N squared plus 2n plus 1. So therefore it became that summation of n square, summation of 2n to n and summation of n. So in that process you can calculate, right? You can see other videos there. In that process we already explained that technique, right? But here we just use that thing called that change of variable, okay? So here see that here that n plus 1, right, this particular variable, right, is used, n variable is used, where n from 1 to 10. Now let us consider that I in new introduction variable that goes from n, that is from n equal to 1, right? Let's see that, okay? So here for that particular problem we just consider a transformation that I is equal to n plus 1. So if I is equal to n plus 1 I consider, so whenever n is equal to 1 I is equal to 2. And when I is equal to 11 for n equal to 10, and that's it, right? So therefore this summation now can be converted to I is equal to 2 to 11 and whatever there, okay, I square. Now this sum is well known, but only you know that we can already add that sum if it is I is equal to 1 to 11, right? Because then that gives you that sum of first 11 natural numbers. So just add 1. So that's why this sum can be written as I is equal to 1 to 11. So I add 1 in that summation. So I need that subtraction, right? That's it. Now this is sum of n natural number square, so we can apply that formula n into n plus 1 to n plus 1 by 6. So that's it. Now if I do the calculation, right, we'll get the final desired value. So that's why I'll give that answer as 16 by 25 into 505, because we are need to find the value of m, okay? That's it. So in that particular case we see that the final answer is actually 99, okay? So that's it. So we can cancel out that because it's 16 by 5 and all that stuff. So that's why for this particular problem option D is the correct answer. Hope you understood the problem, and that's it. Thank you.